NASA's made a stunning discovery on the icy moon of Saturn, Enceladus. They've discovered that the moon is spewing out phosphorus, one of the key chemical elements required for the existence of life. And possibly, the phosphorus concentration in subsurface oceans of Enceladus is hundreds of times higher than in Earth's oceans. With this, all the major chemical elements required for claiming habitability have now been found on the moon. This discovery has made Enceladus the most promising place where life could exist in the solar system beyond Earth. So, how did NASA make this exciting discovery? Why is phosphorus considered to be a key ingredient of life? Finally, and most importantly, how will this discovery impact our course of future missions to Saturn? Enceladus, Saturn's sixth largest moon, was initially discovered by William Herschel in 1789. However, our knowledge about it remained limited until the Voyager 1 and Voyager 2 spacecraft flew by Saturn in 1980 and 1981, providing some insights. But it wasn't until the Cassini spacecraft began close flybys of Enceladus in 2005 that we truly discovered its captivating surface and environment, bringing it into the spotlight. Despite being only about 1/7 the size of Earth's moon, Enceladus exhibits a diverse range of features, including both ancient, heavily cratered regions and young, tectonically deformed terrains. However, there was much more to unravel. Contrary to its initially presumed frigid and inactive nature, Enceladus surprised scientists by revealing a subsurface ocean beneath its icy crust. Not only that, but water from this hidden ocean was observed erupting through cracks, creating powerful water jets. These jets are believed to be triggered by the gravitational forces exerted on the moon by Saturn, which in turn heats Enceladus's rocky interior. As a result, pressurized water squirts through cracks in the ice, propelling into space at tremendous speeds. These geysers release icy water particles and gas at speeds of approximately 400 meters per second, equivalent to filling an Olympic-sized swimming pool in just a couple of hours. While much of the material falls back as snow on the moon's surface, some of the jets contribute to the creation of a plume that nourishes Saturn's faint E-ring, located beyond its brighter main rings. During its flyby of the ringed world from 2004 to 2017, Cassini flew through the plume and the E-ring several times. Doing so, it was hit by these particles originating from Enceladus's interior. And thus, by following and analyzing the data collected by Cassini, scientists got introduced to the spectacular chemistry that the moon was hosting beneath its deceptively calm and white surface. The ice grains from the moon were recorded to contain a rich array of minerals and organic compounds, and the highlight was the ingredients that form the base for amino acids that further are the building blocks of life as we know it. The analysis of Enceladus's ice grains performed over the years revealed concentrations of carbon, hydrogen, nitrogen, with a tentative detection of sulfur as well. Some simulations also suggested the subsurface ocean to be moderately alkaline. All these factors favor habitable conditions. However, there was a key element missing from the list of ingredients to claim a habitability possibility. And that key ingredient was phosphorus. Although it's the least abundant of all the essential elements necessary for biological processes, it has a fundamental role to pave the way for life to prosper. For example, it's one of the building blocks for DNA, which forms chromosomes and carries genetic information. On Earth, it's present in the bones of mammals, cell membranes, and ocean-dwelling plankton. Not only this, but phosphorus is also a fundamental part of energy-carrying molecules present in all life forms found on Earth. To put it in one sentence, life wouldn't be possible without phosphorus. So far, this critical element had not been detected in an ocean beyond Earth. In a recent study utilizing data collected by Cassini's Cosmic Dust Analyzer, or CDA, Between 2004 and 2008, scientists have made an exciting discovery: the presence of phosphorus in Enceladus's ocean. Surprisingly, the detected quantities of phosphorus exceeded earlier expectations. This valuable information was obtained from the CDA mass spectrum analysis of over 300 ice grains from the E-ring. When a dust particle impacts the sensor of the dust analyzer, its trajectory determines whether it hits the central rhodium target, known as the chemical analyzer target or CAT, the surrounding gold target, or the inner wall of the instrument. If a dust particle impacts the CAT with sufficient energy, it vaporizes and becomes partially ionized. This creates an impact plasma consisting of target and particle ions, as well as electrons, neutral molecules, and atoms. The instrument then separates the plasma components and analyzes the resulting mass spectrum of the ions produced by the impacting dust particle. By examining the mass spectra, scientists can gather information about the mass and relative abundance of the fragmented ions, allowing them to deduce the structural characteristics of the original molecule or element that impacted the dust analyzer. In the case of the CDA mass spectra of E-ring grains sampled by the Cassini spacecraft, the presence of sodium phosphates was revealed, indicating the detection of phosphorus. The results obtained by Cassini were confirmed by lab experiments on Earth. Now, the question arises: where does this phosphorus come from? On Earth, phosphorus is released into the environment through the erosion and weathering of terrestrial rocks. However, Enceladus lacks such geological processes. This has led scientists to propose that interactions between the Moon's ocean water and the rocks forming its core may result in the dissolution of significant amounts of phosphorus into the ocean. Phosphates have commonly been found in comets, so if rocks forming Enceladus's core contain phosphates, it wouldn't be surprising. However, the remarkable aspect is the fact that these phosphates are being dissolved into the Moon's subsurface ocean, providing the missing ingredient for the potential development of life in this environment. While having these ingredients is a necessary condition for life to exist, they may not be the only requirements for a potential extraterrestrial environment to support life. Therefore, whether Enceladus's ocean can be a suitable habitat for life remains an unanswered question at present. To explore and uncover the answer to this intriguing question, future missions are needed to build upon the incredible legacy of Cassini. Recently, astronomers made a groundbreaking discovery. They finally detected the gravitational wave background, or the big hum, of the cosmos. It's a significant discovery that can open doors to new physics. So if you missed this episode, be sure to catch up on this intriguing finding.